Hey folks, how we doing today? We have this rooftop unit. It is a light commercial unit, and it's actually at a rooftop. Okay, now this unit is now running. We have turned the thermostat on. The air handler inside is running, but this unit is not running. So we have opened the electric panel access. Just looking at this is not a good one, but it's okay. What we have observed is that the plunger in the contactor actually pulls down, right? So the next thing we did is to verify if there is high voltage power getting in, that's 240 volt, getting into this contactor, but there was none. We used our multimeter, there's none. We came back to this disconnect close to the unit. We open it and the load doesn't have any power. That means there is no power, 240 volt, coming into this unit at this point. So what we are going to do now, we're going to look for the main circuit breaker and make sure that it is in the on position. If that circuit breaker actually trips off, then we're gonna turn it on. And before we turn the main circuit breaker on, we make sure that this disconnect is off. So we will turn it on if it actually trips off and will come up here. The reason why I turn this on off, I put in the off position, it is because I want to power on this unit and I observe how it's going to respond when it receives the 240 volt. The issue might be that the compressor is burnt out, or there's a short circuit somewhere that is actually affecting that breaker, right? Looking at this disconnect is not actually a good one. If there's any shortage, right, it's not gonna break or disconnect the power going into this unit. It might only affect the main circuit breaker depending on the amperage drawn. This is just like a switch. There's nothing here that can protect this. It's not a fusible disconnect or anything. It's just like a switch to power on and off. So definitely if there's an issue with this unit here, it would affect but the main circuit breaker. That's why we turn this switch off, we kill the power, and we are going now to the main circuit breaker and to verify. So that's how you should do it. But at this point, the plunger there at the contactor has pulled in. That means the thermostat has sent 24 volt here. It's 24 volt getting in here. The low voltage is getting in here, but it will not power on because 240 is not getting into that unit. So let's go down there and locate the main circuit breaker and see if it's tripped off. If it is in the off position or it has tripped off, then we will turn it on, come up here and turn that disconnect on. If we turn this disconnect on and immediately it trips off again, it means there's an issue here, and we'll continue our diagnosis. It can be a burnt compressor or a grounded compressor or the motor or something. So let's go and look for the main circuit breaker. Okay folks, right here at the main circuit breaker, look at this, the 40 amp. It has tripped off, so it's labeled here. The AC is 135, so this is it. What we're gonna do now, we're gonna turn this on. Let's first of all turn it on. It's not in the on position, so up there we should be receiving power. So let's go up there and we trace it and see if actually how it's gonna work with that unit. We have turned on the main circuit breaker on, and let's now power this unit. So there should be power getting into this disconnect now. from the main circuit breaker. So let's power on and listen to the response of this unit. If it immediately trips off, then we'll go ahead to do a diagnose on the main components of this unit. That's the motor and the compressor, okay? To make sure that there's no grounded wire or any high voltage wire that is grounded, or something is happening, or the unit is pulling higher amperage. So let's go ahead and power this on. It's running. Let's wait for a while. So it does not trip off. No, the motor is not running. So let me take it down. The motor is not running. Okay, the motor is not running. The compressor comes on, but the fan motor is not running. So at this point, we are assuming that the motor should be the issue, but let's test the motor. Okay, let me just use this. When it's off, just try to push the motor. It's flexible. The rotation is good. It's flexible. If like it's tightening, means that it's off. So at this point, we're gonna check our capacitor. Okay, let's check our capacitor. Maybe capacitor is that, but this thing is flexible. So if you test our capacitor and it's okay, but it's not running, that means the problem is the motor. So let's go ahead and we'll test our capacitor. I'm going to show you how to test this capacitor. Okay, let's go. I'm going to kill the low voltage coming into this unit. Before we can do anything, let's pull this out. Let's de-energize the coil, the contactor coil, and be careful. This is not supposed to have any contact anywhere. Then from there, we'll go ahead and disconnect this capacitor. Okay, let's disconnect this capacitor and test and do a test capacitor. Okay, I think this should be 5 microfarad. I'll see what they put here. Should be 5 microfarad. Take this out, and we are going to take off all these wires from the capacitor before we test if it is working. Okay, so we set our multimeter to MFD, that is for the microfarad, and this is the common terminal and this is the fan terminal. So with the common and this one should read 5 microfarad. Okay, if it doesn't reach 5 microfarad, that means it's not moving. With the common and this and the compressor, we should reach 60. I think this is 60. So let's start with this and the fan that is not working. We don't have anything. Let's take this, and we have removed the old capacitor, and we're gonna see if actually it is having the 60 microfarad and the 5 microfarad, depending on the terminal, right? So we set our multimeter to MFC, that's microfarad, because we are testing for the capacitance. And let's start common, and this is reading nothing. That's the common and the fan terminal. Okay, So let's use the command. The command and the compressor. Command and compressor, nothing is reading. It reads 0, 0. So let's test this one that we assume it is working. That is the common. And this, that is for the fan. We have 4.95, means this is a good one. Then let's also use command and compressor. We should have 60, right? Average 60. So this is a that one from this unit is bad, so we're gonna replace this one. Okay, that's 60 by 5 microfarad. We're gonna replace it. That means the compressor takes 60 and the fan motor takes 5. So that is the situation here. We're gonna replace the capacitor, and I believe the unit should be good to go. So we have put in the new one, and we're gonna run the unit now and see how it runs. Okay, if the fan motor doesn't run again, that means the issue should be the fan motor. Let me send back the low voltage. Power, and then I power this on now. Okay, you see it's running. The fan motor is running. That means the issue was the capacitor. But the question is, how would a failure in the capacitor affect the 40 amps breaker? So what we're gonna do here, we're gonna wait for some time to see the reaction. Maybe with time, we're gonna pull higher amperage, or better still, we should be able to measure the amperage drawn of the blower motor and the compressor, because that's the only thing that can actually like trip the breaker off. But it wasn't running, now it's running. Let's wait for some time and see how it's going to work. If the circuit breaker trips immediately, that means there's a shortage, or there's a grounded wire, or there's a burned compressor or motor somewhere. Okay, but at this case, that's not what we are concluding on. So what we're gonna do, we're gonna wait and for a moment and see how it works. Feeling this is actually cooling. And thank you for watching, guys. See you in the next one. If you like this video, please give a thumb up and you subscribe. Thank you.